Okay, so this is the solution I've cooked up, or part of the solution I've cooked up here in Python for how we can implement CNNs with our data set. I hope you just finished listening to the little talk slash lecture I uploaded. If not, this isn't going to make too much sense, so go back and listen to that. Um, but if you are here, then let's get into this. First, we have the load libraries here, and this code should be uploaded in Teams or attached to the email you got. So look for it there, and if not, yell at me on Teams, and I'll send it your way. Next, we're going to load in the data. We're going to do something unique here that you might not have done in the past, where we load in the data. This should be the path. You can change this to wherever you put the data. And then we're going to break it up into units. What this chunk of code here does is it creates a dictionary. Dictionaries are organized into key value pairs. So it has a list of keys, and every key then has a corresponding value, which can be anything. It can be a pandas data frame, it can be an integer, it can be a huge array. And so it's a way to store data that isn't rectangular, right? Let's say, for example, one unit is 100 time steps long and the other is 1,000. How do you store those together? You do it in a dictionary because it doesn't care what the size of the individual values are as long as they're assigned to keys. So that's basically what we do here. And we give each of the units, you know, a key that is their number. It's a string. And so what it's going to look like, what I should have put here before, is unit one looks like this, where it's a pandas data frame, goes from 0 to 191, and has all the columns here. You'll notice too that we got rid of here, we got rid of the time, we got rid of the unit number, and we got rid of one more thing. Oh, like an indexing thing that's from an indexing column that's from the CSV. We did this to clean it up because we don't want to include those in the image because it gives too much information, basically. If we gave it the time, then I mean, that is just the remaining useful life, but backwards. So that we don't want to give necessarily to the CNN. And that's something we mess around with. Right, once we have this, the meat and potatoes of this code starts, which is putting the data into the correct format, which is all of this here. The main idea of this is to take this time series data, which looks like this, and put it into images that the CNN can process. Now, you might think that's really easy. Oh, we'll just make an image that's 191 rows by 24 columns. Unfortunately, every single unit is of different length. So the next unit after this, I think, is like 250 time steps. And the next one after that is so forth and so on, whatever. But CNNs can't necessarily be trained to consider images of different lengths. There are ways to do it, which we'll get into outside of the thing I implemented, but they're complicated and they might be unnecessary. The other thing we want to do is we don't necessarily want to just pass in the entire unit, the entire run to failure data set as a single image. We might want to split it up. The thinking behind this, which is outlined in the article I posted in the CNN Teams channel a while ago, is that you train the model to recognize, chunks of data like 5 seconds at a time and assign that as either failing or not failing. Right. So then when you have live data coming in 5 seconds at a time, you can then plug that into the model and it can assign it failing or non-failing. If, for example, you pass it the entire data set, and let's say you train it really, really well, um, you know, then what it's going to, well, one, it's going to have difficulties kind of tagging what this data set is. Like you can get it to bring out a vector that goes, not failing, not failing, not failing, failing, but that's going to be a little tricky. And secondly, it's not going to be very helpful because then to apply it to anything, you're going to have to pass it in the entire time series data again. And if you have the entire time series data of like live data, that means it's already failed, right? Instead, you want to get chunks of it so that when you are getting chunks of data in the real world, you can tell if it is going to fail or it's not going to fail. This is just kind of an example of how, having a full data set of a run to failure thing doesn't necessarily mean your work is done for you. You still need to cut it up to reflect how you're going to look at it in the real world. So let's get into that. This is a function I defined just to make things easier. It's called down here. This is really all you need to know here. You give it the time step for the chunks to split it into, which we'll get into. You give it the data and it outputs the X, which is going to be the images, and the Y, which is going to be the labels. So this is going to be the images that are the size of the time step, which we'll get into, and this will be labeling whether they are failing or not failing. And in fact, I can actually maybe improve that. We can talk about it. But let's get into what this actually does. So it starts off with making these, which are used later down. They're basically dictionaries again, because each of the images are going to be of different sizes initially, and we need to store them in a non-rectangular data set. Then what this does here is, oh gosh, I coded this last night. I maybe should have reviewed it before I took a look. Okay, no, yes. So this looks at a single unit at a time. It goes from 1 to 100. And every time it looks at a unit, this just makes the unit the I a string, so it can be used to index the dictionary. It creates a failure array or a label column, basically. So this is a one-dimensional vector that is 0, 0, 0, 0, 0 until it fails. What this is doing here too is, and we'll get down into that more here, is it's basically setting that when it fails, set it equal to 1. This right here, and I maybe should comment to make it more obvious, but this section right here is what you guys are probably going to change the most, because when you are playing with the data, the idea of a labels that are just 0, 0, 0, 0, 1 into failure isn't the most helpful and might not be enough for the model to learn. Instead, what you want to do is probably like 0, 0, 0, 0 until you get to the last 25, 10% of the data, and then label that 1. And so rather than it switching to 1 when it fails, it switches to 1 when it fails. Because if you think about it from the model's point of view, if you have a vector that is all zeros, it's a 200 zeros and then a single 1. Well, if you output a vector that is all zeros, you're only like 1/200th of incorrect, right? So you're pretty close, and so it's easier for the model to learn if it has more data to work with instead of just a single value at the end. But so that's what you're going to mess with here, because at the moment it just sets the last value to 1. All right. This here then creates a new array. This whole line here, this is the Python thing that splits the line so it doesn't go off the screen. This creates a new array that you are going to put your images into. It is the shape here of the length of the time series data. So for unit 1, right, it's going to be 192 rows plus, and here's the tricky part, plus whatever is needed to get it to be divisible by 5. The reason this is done is because we are chopping up all of these different unit runs of different lengths. We are chopping them up into chunks of 5 seconds at a time. That is what this time step is, which you define. It defaults to 5 because that's what I thought was a nice round number. It could be anything. It could be 10, it could be 50, it could be 100. But basically it looks at every single unit, and to make them all the same step, it just makes them into different numbers of 5-second, like, screenshots of the data. And so that's what this does here. It's going to have the number of rows that is required to fit the data, plus whatever is required to fit the data and make it divisible by 5. And then the columns, or and then it'll be the next dimension will be the number of columns. So for this example here, instead of 192 rows, this is the first unit again, and 24 columns, what this X array is going to be is 195 rows by 24 columns. What's going to be in that last 3 rows, the last 3 rows here that are added is just all zeros, which the model ideally will quickly learn to ignore. Then what this goes through is it goes through every single row, and for every row, it goes through every single column. And for every single column, it puts it into the appropriate column here. So it basically just populates this array with the data from the pandas data frame here. And you can see that it only considers the rows from 0 to the length of the pandas data frame up here. It doesn't consider the extra rows added here to make it divisible by 5. So those rows stay as 0. Then it comes over here and uses numpy.split to split the this array into a series of arrays, each of length 5. And we can do this, right? We can just split X divided by the time step because we've already made sure up here that X is divisible by the time step. And so these new lists, I believe, Yes, these new lists are going to be a list of, for this example, 195, 39 arrays, which are 5, which is the rows, times 24 columns. And it does this for the Y data as well. And because the Y data is the same shape as the X data, well, it has the same number of rows as the X data, right? You see this is identical to this, but it only has one column, which is the failure state. It does the same thing here, so you get the same number, or it does the same thing here, so you get the same number of chunks of the same shape, but it's just 0, 0, 0, 0, 1. Okay. Now I'm going to create a new 3D array with the split data. And what this is going to be, and I guess I should have done this outside of the function so we can see the shape of all of these, but basically it takes this list and then it stacks them. So if you have, oops, let's just write it out here. I keep hitting the key. Okay, so if you have a list of 10, 5 times 24, sorry, give me a second here. Okay, so if you have a list of 10, 5 by 24 arrays, right? And then you have another unit that has 7, 5 times 24 arrays. What this then does is it puts it into a single array that's going to be 10 times 5 times 24. And actually, we won't worry about this second set of data yet. So this is what this X chunk does. Let's actually go through this in a little more detail then. So using the example of unit 1 is in the shape of 192 times 24, 192 seconds times 24 columns. Then we do this part here where we create a new array that is going to be 195, the closest, divisible by 5 number from 192. That is adding, because we don't want to get rid of data. We don't want to drop 2 rows. So we just add 3 times 24. And that's what this does here. It populates that array with the actual data. Then we get to split. And what split does is it does 39 list entries of 5 times 24. So it splits these rows into 39 arrays of 5 seconds by these 24 columns. And then what X chunks does over here is it then puts that into a new array of 39 times 5 times 24. So the reason this is split up into 2 steps is just because that's the way I thought about doing it. There might be a better way. And the same process has gone through with Y, except instead of 24 rows, there's just 1. Or 24 columns, there's just 1. Okay. Then what does this do? Oh, yes. Then this is simply the loop that populates these arrays with the actual data. So it pre-allocates the arrays here, and then it goes through down here and populates that with the data. And then finally, they are all put into a dictionary. The dictionary is defined up here outside of the loop. It's pulled into a dictionary with a key value of the unit and then the number of chunks. So it ends up in a dictionary that looks like this. It's going to be X final, the first unit, and the shape is going to look like, let's do that so it's not equals. The shape, whoops, the shape is going to look like 39 times 5 times 24. We need this to be a dictionary though, because remember, this is all in one big loop here that's going through all the units. So it goes through this once for the first unit, then it's going to go through it all again for the second unit, except the second unit is going to have a different number of images. It's going to be like 48, right? Still 5 times 24 because we make sure that each unit is divisible by 5, but a different number of these images because the units are different length. Then once we have all of this, every from 1 to 100 of the units within this dictionary, all within these shapes, we then here outside of the loop, put them together into a single dictionary or a single array. And the way we do that is first we iterate through all of these xfinal, all of these dictionaries and count the number of images. We count this value right here, this dimension for every single unit from 1 to 100. And we get a total count. So then that allows us to define a NumPy array that has that as the first dimension then the time step as the second, and then the columns as the last. And then we simply iterate through this dictionary again, and we save all the data to the new array, all that is of the shape total images times 5 times 24. And so we basically stack all of these into a single array that I believe is like 4,000 times 5 times 24. And we do the same thing for Y, except the only difference is that it's a single column instead of 24. And then we return these two. So we do this entire process. We do it here. And we're going to get something like x dot shape. And you can see, excuse me, I got to have a sip of water. Okay, you can see the result is that we have every single unit divided up into these 5-second increments with all the columns stacked on top of each other. And so if we were to look at the original data with all the units still in, in there, right? If we look, this is the original data loaded in before we did anything. And you can see that the units are all here together. The length of this data is, that's not what I want to do. Oh, you have to do it. Forget it. But basically, we can just check that this is indeed all the data, and it is all there. And then we look at the Y dot shape, and we get the same thing, but except remember it is only one column, and so it doesn't even show it as a column, but the 5-second increment. And if we want to check that the data is still present, we can go back to unit 1 example and remember, oh, there's 39 images of 5 seconds in the unit 1. So we go to X and we look at the 39th row, which is called 38 because it starts counting at 0. And this is what we get. But really what we want to check is in Y that indeed it clocks that it fails at 192 seconds. Remember, these 3 rows, these 3 zeros are simply to make it divisible by 5, but this is where the first unit fails right here. And so we preserve that, and it's here in the X and Y. I hope that wasn't too complicated. I tried to comment some of it here, and you can go through and read for yourself. The big takeaway, though, is that it does most of the work for you. You just have to define your time step, which is here 5 seconds. It can be anything. It can't be longer than the shortest unit number. Well, I suppose it actually could. I don't know what that would do. Just don't make it too big. You just need to pass it the time step and the dictionary with the units. Then we get into here, which is the model. And I don't want to go over this too much because this is the work you guys should be doing. But basically here we see a convolutional layer, a max pooling layer, a flattened layer, and then here is the fully connected layer, split into 2 dense layers, which is just a type of fully connected layer in TensorFlow. And then compiles it all with the loss being mean squared error, basically the numerical error between what the neural network spits out in all labels. And you can check here and double check that each of the shapes are going to be correct, right? This is what it outputs. This is what it outputs. Yep, it looks like, nothing seems crazy here. This is going to be more or less the shape we originally put it in. Well, not really. That should be, this should be 24 because that's what it's going to be sized. And then we can come down here and test it. And it should run pretty quickly, as you can see. Now, I'm not going to show you guys that because that's what you should do. But you can see it ran 10 epochs in 3 seconds, and you can see the loss here is not very good to begin with, but then it gets down here, it starts diverging again. So you guys have to mess around and see how to do this. That is basically the code. This workbook is going to be uploaded to Teams and attached to the email. You got this link through. Your job then is to simply mess around with, your job is threefold. One, it's to mess around with how to process the data, what size image to put it into. Should it be 5 seconds? Should it be 10 seconds? So forth and so on. You also want to mess around with what the label array should look like, which again is this section here. Should it just be a single 1 at the end when it fails and 0s all else? Or should it be the last 10 steps are 1? Or should it be something else? Should it be remaining useful life that counts down? That's up for you guys to decide and experiment. And then lastly, you'll want to, then you'll want to train the data, right? You want to train it on different stuff. It doesn't cost anything to run the model, so run it a lot with the different parameters. Run it, try and train it with this. Try and train it with the last 10% of the data label. Try and train it with the remaining useful life. Train it with 5 seconds as a time step. Train it with 10. Try a lot of different things. Then the last thing you have to do is you have to sit down and think and talk amongst yourself if whether this process of splitting the data up into images is even a good one, because there's other ways we can do it, and you can sit down and think about how we can get these differently sized units into standard images and so forth and so on. So that's the 3 things to do, which is mess with how we process the data, train models, and then theorize about better ways to process the data. I hope this wasn't too long-winded. I hope that I didn't get too bogged down into the weird shape stuff of arrays and the such with process data. I hope I didn't skip too much. As always, if you have questions, let me know. And I apologize if this went too slow or too fast.